Hello friends, welcome to Risingpearl.com. Today we're starting a brand new series 5 called Polynomials. This is episode number 1, and friends, today's topic is what is a polynomial. I'm calling this a refresher, this webisode a refresher, because we have learned what is a polynomial and the basics of a polynomial in our earlier episodes. So going forward in this series, whenever I see appropriate, wherever I feel there is a need or it may be of value to you, I'm going to provide the links and URLs of the videos that we have covered in our earlier grades for your easy reference. So friends, let's take a look at what are we going to learn today in this episode. We will take a look at what is a polynomial. Equally important is we are going to make sure that we understand what is not a polynomial, because the rest of the series will focus only on polynomials. Then finally we are going to take a look at what is the degree of a polynomial, and then what is a linear polynomial, what is a quadratic polynomial, and what is a cubic polynomial. So friends, let's get started. So what is a polynomial? Polynomial is really an algebraic expression. So it's an algebraic expression where exponents of the variables are raised to whole numbers. Now, so it's an expression where we have variables, that's important. And secondly, exponents means the powers, right? So the variables will have powers, and these powers must be raised to whole numbers. Now we know what is a whole number. We know the set 1, 2, 3, 4, so on and so forth, all the way till plus infinity. This collection of numbers, we call them whole numbers. So if we have an algebraic expression where we have variables which are raised to the power of whole numbers, then we call those expressions polynomials. So let's take a look at some examples of polynomials and some expressions which are not a polynomial. So I'm going to write some expressions. So let's write something like maybe 2x plus 3. Now, is this a polynomial or it is not a polynomial? This is clearly a polynomial because we have two terms. The first term has a variable x, and here x is raised to power 1. We know when there is no power mentioned, then that means it's raised to power 1, and 1 is indeed a whole number. So this is a polynomial in variable x where it is raised to power 1. And as you know, we represent polynomial in this fashion. So this is a polynomial, P for polynomial, and polynomial in variable x. So x is the variable. So similarly, if we write something like, let's say, y squared plus 2y minus 10. This is again a polynomial in variable y this time. We have three terms. First term is raised to power 2. Y is raised to power 2. The variable is raised to power 2. The second term, the variable is raised to power 1. So, and the third term has no variable. So this, the entire expression is a polynomial in variable y. So we write this as p within brackets parenthesis y for the variable. And let's write something like, let's say square root 3 u cube plus, let's say, 5u squared. Now here u is a variable and we have two terms. It's important to note, friends, here the first term, the coefficient actually is an irrational number, but we don't really care or consider the coefficient. We are only looking for the variable or the variables and what is the power to which the variables are raised. As long as they are raised to whole numbers, then we say they are polynomials. So here the variable is u. The first term u is raised to power 2, and in the second term u is raised to power, the first term it is raised to power 3, second term it is raised to power 2. So we say this is a polynomial in variable u. So yes, these are three examples of polynomials. Now similarly, if we write 5, now is this an algebraic expression? But this is not a polynomial. This is basically, this is an expression. Obviously you know this is a number, but this could be thought about as an expression with only one term, and it's a constant term, so it has no variables. So this is not really a polynomial. Alright, how about 1 by x plus 5? Now, is this a polynomial? This is clearly an expression because we have a variable term. But now, 1 by x can be basically thought about x raised to the power minus 1, right? So, minus 1, now is this a whole number? No, the whole number is basically starts from 1, then goes 1, 2, 3, 4 to plus infinity. Minus 1 is not a whole number. So we have an expression where the variable is not raised to a whole number. So this is again an example of not a polynomial. Similarly, if we have something like maybe 1 by t squared minus t plus 5t. Now here we have two terms. So this could be, we can think of this entire thing as the first term, and this is the second term. Now this expression, the second term, so we have a expression in variable t as in Tom. The second term is raised to power 1, right? T is raised to power 1. But the first term, we have t, which is in the denominator. So again, this cannot be raised to a whole number. In this first term, the variable cannot be raised to a whole number because the entire thing is 1 divided by, so it's all the variable terms are in the denominator. So this is an example of not a polynomial. So again, just keep in mind one quick thing though, like the way the coefficients don't matter, it is the variable to which that is raised. So in this case, if instead of 1 by t squared minus t, if I had something like 1 by 5 t squared, this would have been a polynomial because we don't really care about the coefficient when we decide whether it is a polynomial or not. So in this case, because my variables are in the denominator, this is not a polynomial. So these are not a polynomial, not a polynomial, not a polynomial, but this particular expression ideally should be here. So this one is a polynomial like each one of these. So friends, I hope you have a good understanding of what is a polynomial, what is not a polynomial. Let's talk about what do we mean by degree of a polynomial. Now the degree of a polynomial is the highest power to which a variable is raised in a polynomial. We say that is the degree of that polynomial. So let's take some examples. So let's say 2x plus 5. Now this is a polynomial in variable x, and here the first term x is raised to power 1. So there is only one variable term, and that is raised to power 1. So we say degree of this polynomial is 1. Now let's say we have y squared minus 2y. So here we have a polynomial in variable y. There are two terms again. Now the first term, the variable is raised to power 2. In the second term, the variable is raised to power 1. Since 2 is greater than 1, so this degree for this polynomial is 2. Remember, we are looking for the highest power to which the variable is raised. So when we have multiple variables, we are looking for what is the highest power to which any of the variables is raised, right? So similarly, if we have, let's say, x plus 2x squared plus 5x cubed plus say 7. So here we have there are total 4 terms in this polynomial. This is the polynomial in variable x, and there are 3 terms that have variable. So 1, 2 and 3. The first term is raised to power 1, second term is raised to power 2, third term is raised to power 3. So 3 is the highest power to which any of the variables are raised. So we say degree of this polynomial is 3. Now what about the degree of this polynomial? Now this is a trick question because again the variable is in the denominator, so this actually is not a polynomial, and so we are not going to talk about the degree because this is not even a polynomial. Now friends, let's talk about what do we mean by linear polynomials. Quite simply, if the degree of polynomial is 1, then we call that polynomial, linear polynomial. So if you have 2x or 2x plus 10 or 5y or square root y plus 3. So in each case here, if we have one term, x is raised to power 1. So this is a polynomial of degree 1. So this is a linear polynomial. Here we have two terms, but we have only one variable term, and in that the variable is raised to power 1. So this degree of this polynomial is 1. So this is again a linear polynomial. Here we have one term, variable is y is raised to power 1. So this is a polynomial in variable y, and it is a linear polynomial. Here we have two terms. So the first term has the variable y, which is raised to power 1. So again, this is a linear polynomial because the degree of this polynomial is 1. So these are all examples of linear polynomial. We are simply looking for the degree of the polynomial to be 1. If that is the case, we say that is a linear polynomial. Now, what about quadratic polynomial? Whenever the degree of polynomial is 2, it becomes a quadratic polynomial. We say it is a quadratic polynomial. So, let's say y squared plus 2y. So here we have a polynomial. There are two terms. The first term, it's a polynomial in variable y. So y is raised to power 2, and here y is raised to power 1. So clearly degree of this polynomial is 2, and so this is a quadratic polynomial. Similarly, let's say you have 1 by 10 x squared minus 5x plus square root 3. So here we have three terms, and if you look at each of the three terms, we have the variables are x. So this is a polynomial in variable x. So the two terms have, so this term and this term have the variables, and this is a constant term, right? This is a constant term. So if you look at the first two terms, here x is raised to power 2, and here x is raised to power 1. So that's why we say this is the polynomial in x with degree 2, because 2 is the highest power to which the variables are raised. And so if it is a degree 2, then we say that is a quadratic polynomial. So this is again an example of a quadratic polynomial. So similarly, you can think about, let's say, x squared minus 10. This is another example of a quadratic polynomial because the first term is the variable x, where it is raised to power 2. So hence degree of this polynomial is 2, and it is a quadratic polynomial. So whenever we have a polynomial whose degree is 2, we call it a quadratic polynomial. And finally, we are going to take a look at what are cubic polynomials. So simply, when the degree of the polynomial is 3, then it becomes a cubic polynomial. So some examples are simply t cubed. This is a variable, this is a expression, this is a polynomial in variable t, which is raised to power 3. So the degree of this polynomial is 3. This is a cubic polynomial. Similarly, if you have 5x squared minus 10 plus x plus 2x cubed. So here we have this polynomial. There are 4 terms, 1, 2, 3, 4. This polynomial is a polynomial in variable x. So we have x as the variable. Now if you carefully look at the degree of the polynomial, you will see the first term, the third term and the fourth term have the variable terms. So first term is raised to power 2, the third term is raised to power 1, the fourth and final term is raised to power 3. So this is a polynomial in x where the highest power is 3. So degree of this polynomial is 3, and because of that, this is a cubic polynomial. So let's write probably one more. So how about if we write y plus y cubed minus 10 plus 5y squared. This is again a polynomial in variable y, and here the maximum power to which the variable y is raised across all the terms is 3. So degree of this polynomial is 3, and as such this is a cubic polynomial. So friends, this was a quick recap of what is a polynomial, what is not a polynomial, degrees of polynomial, and linear, quadratic, and cubic polynomials.